today we're looking at absolute value and solving simultaneous equations, or what you may know as a system of equations. So absolute value. This sign right here is the absolute value sign. You may have heard it called modulus. It means the same thing. So modulus, or absolute value, is the size of the number ignoring its sign. Or another way to think about it is the absolute value of x is the distance from x to 0 on the number line, or 0 to x. So, for example, the absolute value of 3 is just 3, because from 0 to 3, that distance is 3. Okay? Same with negative 3. The distance from 0 to negative 3 is 3, and so the absolute value of negative 3 is 3. So if you put a negative number into an absolute value, you're just going to get a positive number out. If you put a positive number in, you still get a positive number out. So the definition of absolute value is exactly this. So the absolute value of x is equal to x if x is positive, or equal to 0, and then it's equal to negative x if x is a negative number. In other words, the opposite of x. Or here's another way of saying that. If you take the square root of something, you're going to get a positive value. So if you first square negative 3, so anytime we square something, it becomes positive, right? So that's 9. And then if we take the square root of 9, we get 3. So the absolute value of negative 3, or squaring and then taking the square root, is another way to explain absolute value. Okay, long story short, we are going to apply this. We're going to solve absolute value equations. So for letter A here, we have the absolute value of x is equal to 3. So as we just looked on the previous page, that means that x could be 3 or x could be negative 3. Right? If we put negative 3 inside the absolute value sign, we still get 3 out. Okay, so x is positive or negative 3. Another way to write that is x is plus or minus 3. Okay. Letter B. Letter B, there is no solution. No solution. Another way to say that is to use the empty set sign. So you can give that as a solution, or you can use DNE, which stands for does not exist. Okay, the reason there's no solution to this is because there's no way that we can put a number into an absolute value sign and get a negative number out. It just cannot happen. Anytime you put a number into an absolute value, you're going to get a positive number out. So this doesn't exist. There's no solution there. Okay, for letter C, the absolute value of x is 0. Well, the only thing that x can possibly be is 0. 0 is neither positive nor negative, so it's our only solution there. Okay, for letter D, we're going to say that whatever is inside the absolute value is equal to positive and negative what's outside the absolute value. Okay, so we'll say that x minus 1, because that's what's inside the absolute value sign, is equal to a positive 3, and we'll also solve x minus 1 is equal to negative 3. So we're going to write it as two separate equations. Okay, we're going to add 1 to both sides, and x is equal to 4. Here when we add 1, we're going to get x equals negative 2. Notice it's not, for a final answer, it's not plus or minus 4 or something like this. It's positive 4 and it's negative 2. So be careful to write two separate equations when solving those. Okay, letter E. We've got 3 minus x is equal to 4, or 3 minus x is equal to negative 4. And we're going to solve both of those. So we can subtract 3, and we get negative x is 1, so x equals negative 1, or we can subtract through here, so negative x equals negative 7, right? Negative 4 minus 3 is going to give us negative 7, and so x equals a positive 7. And we can check our answers too, right? You can plug negative 1 in for x here. So if we do 3 minus a negative 1, so minus minus turns into plus plus. 3 minus a negative 1, or 3 plus 1, of course, is equal to 4. Or we can plug in 7, because that's what we got for the other solution. So 3 minus 7 gives us a negative 4. And then when we take the absolute value of negative 4, we get positive 4. So both of those give us a solution of 4. So they both work. Okay, letter F, be careful with this one. It's another no solution one, because there's no way we can put something into this absolute value and get a negative number out, right? So letter F is no solution. Okay, be careful not to say, oh, then x plus 5 is equal to negative 1 and x plus 5 equals positive 1. No, if the number outside right away is a negative number, it's not possible. Okay, so there's no solution. You could also write the empty set, or you could say it does not exist. You don't need all three of these, but these are your options for communicating that. Okay, I'll leave the last three for you. You can do those. You can pause the video and then check them. Here are those solutions. Okay. Okay, then we're going to look at simultaneous equations. There's a list down here. We are going to look at 3 different methods that we can use to solve simultaneous equations. So this is an example of a simultaneous equation. Okay. We have 3 different methods we can use to solve this. We'll first look at substitution. So using that first example, so this one here, if we're going to use substitution, and x minus y equals 3, we're going to pick one of the equations and solve for one of the variables. Okay, so pick one equation, solve for one variable. So I'm going to choose the second equation, this one here. So x minus y equals 3. And I'm going to solve for x. I'm going to get x alone by adding y to the other side. So we have 3 plus y is equal to x. Then we're going to take that 3 plus y, which is equal to x, and we're going to substitute it in for x in the other equation. So make sure you don't use the same one you just used. Okay? So instead of x, here, I'm going to write 3 plus y. I'm going to substitute. So 3 plus y plus 2y is equal to 9. And then I solve for y. So I have 1y plus 2y. So on the left side I have 3y. When I add them together, is equal to 9. I can minus 3. And 3y is equal to 6. Divide both sides by 3. And we get y equals 2. Okay, so I have y equals 2, but I still don't have a value for x. The easiest thing to do is then to substitute 2 back into the equation that's already solved for x. Okay, so that means x is equal to 3 plus y is 2, so instead of y I will write 2, and x is equal to 5. Okay, so this is our solution to the simultaneous equations. That means that if I were to graph these 2 equations, they would meet at the point 5, 2. So when x is 5 and y is 2, that is a solution to both of these equations. Okay, so that's substitution. Elimination. I'll use the same letter A to show you elimination. So just move this down. Okay, so again, we will use these 2 equations, x plus 2y is equal to 9, and x minus y equals 3. Okay, with elimination, you're looking to eliminate one of the variables. So you're going to add or subtract the equations together to entirely get rid of one of the variables. So this is 1y. So notice we have 1x and 1x. If we simply just subtract the second equation from the first one, it's going to cancel our x's out, right? 1x minus 1x is 0 x's. They're gone. 2y minus, right, a negative y. So minus a negative means plus. So 2y plus y gives us 3y. And then we have 9 minus 3. So we're just doing this vertically. And we get 6. Okay, so you just go x minus x, well that's 0, they cancel. And then you're going down from here, so 2y minus a negative y gives us 3y, and 9 minus 3 gives us 6. Okay, then we divide both sides by 3 to solve for y, so y is equal to 2. Okay, and then we can substitute y into either one of those equations, so either the top one or the bottom one, and we can find x. So we would substitute it in the top one. Instead of y, we're going to write 2. So 2 times 2 is equal to 9. So x plus 4 equals 9, which means y is equal to 5. Or sorry, x is equal to 5. So we get the same solution as we did with substitution, of course. So elimination, substitution, you can use either one. I'm just going to show you example B. And x minus 2y equals 2. Okay, so example A, that worked out really nice for elimination because we just had 1x and 1x, and when we subtracted those, they canceled right away. Here we don't have the same coefficients with our variables, but what we can do is we can multiply the second one by 2, and then we can subtract them. So then that gives us a 2x, right? And then that'll cancel our x's. You can cancel the y's as well. It's just a lot easier to multiply our x. If we wanted to cancel our y's, we could multiply the first one by 2 and the second one by 5. So we'd get a coefficient of 10 and negative 10. Okay. But anyhow, if we multiply the second one by 2, we will have 2x minus 4y, so we have to distribute 2 to everything, including the other side of the equal sign, is equal to 4. Okay, I'm going to erase this, and we're going to cancel what we can. We're going to subtract these two equations from each other. So we have 2x minus 2x, and that gives us 0. Okay, and we have 5y minus a negative 4y. So minus a negative means plus, so we have 9y. 28 minus a 4 is going to give us 24. Okay, and then we can divide both sides by y. Running out of space. So y is equal to, we can start to cancel things. We can divide both of these by 3. So we have 8 over 3, right? And then to get x, we simply just plug y back into either one of our equations. This was the second equation that we originally started with. It's nice to use that one because it's already got 1x, right? We don't have to divide like we would in the first one. In the first one, to solve for x, we'd have to divide by 2. This one's already 1x, so it works out really nicely. So x minus 2y equals 2. Instead of y, we're going to substitute 8 over 3. Okay. Right, so this is 2 over 1. X minus, we can multiply straight across with our fractions, so 16 over 3 is equal to 2. And we're going to add 16 over 3 to the other side, so x is equal to 2 plus 16 over 3. If we want to get a common denominator, we can make 2 have a common denominator of 3, so that's 6 over 3 is equal to 2. So So 6 over 3 plus 16 over 3. And x is equal to, what is that, 22 over 3. Okay, so we have the point 22 over 3 and 8, comma 3. 22 over 3, comma 8 over 3. Okay, so when is it better to use which method? It's good to be able to use both of them. Substitution is often better when you have a variable without a coefficient, so you don't have to divide by anything. So for example, here you can easily solve for x or y. Here you can easily solve for x. In this one, they all have coefficients. They all have numbers in front of the variables. So it makes it a little more challenging. This one is set up for substitution. Okay, you could easily solve for x and then substitute it into here, right? Elimination is nice when the variables already have the same coefficient, or you can easily multiply to get the same coefficient. Like this one, we could easily multiply by 2, so then we can subtract our x's, right? We get 2x. Here it's already set up for us, so we can right away subtract our x's. This one, we can easily multiply by 2 and then subtract our x's. Oh, and that one you end up subtracting everything. That's a good one to look at. Let's do that. So 2x plus 4y we get is equal to 10. And then the second equation we had was already 2x plus 4y equals 1. So when we subtract these, we get 0x, we get 0y, right? And we get 10 minus 1 is 9. So we have 0 is equal to 9. Remember when we were solving equations, if we got 0 is equal to something that is not 0, it means there's no solution. So there is no solution to this simultaneous equation. And the reason that is because these lines, if you graphed them, they would be parallel. So they never intersect. They have the same slope. So no solution, you could write the empty set. You could write DNE, and that means does not exist. So any of those 3 solutions is appropriate. What else? If we wanted to solve letter C here, elimination works well with the y's. We can easily multiply the first one by 2, and then we have, this will be 4y, right, when we multiply those, and then we can cancel our y's. Here we can multiply the second one by 2, and instead of subtracting them, we can add them. So we'll have a negative 4y plus 4y, and those will cancel. Should we do letter F? Just to work with those fractions. Okay, I'm just running out of a little space. I'll erase this. All right, letter F. If we don't want to deal with these fractions, you can multiply by a common denominator. So here our common denominator will be 6, here it will be 12. So 6 divided by 2, we've got 3x then. 6 divided by 3, we've got 2y. And then don't forget to multiply 6 by your constant here, so that's 30. 12 divided by 3, we've got 4x. And 12 divided by 4, we've got 3y. And 12 times 1 is 12. Okay, so this is our system of equations. Then, if we want to use elimination, we're going to have to multiply both the top and the bottom equation to get a similar coefficient. So we could multiply the top by 4, the bottom by 3, and then subtract them to cancel our x's. Or if we want to cancel our y's, we could multiply the top by 3 and the bottom by 2 to get 6y in both of them, and we can cancel them. Let's do that. So we want to get 6y in both of them. So we'll have to multiply the whole top by 3. So 3 times 3x is 9x. 3 times 2y is 6y. And 3 times 30 is 90. We'll multiply the bottom by 2. So 2 times 4, x is 8x. 2 times 3y is 6y, which is perfect because now we have 6y and 6y, so they will cancel when we subtract them. And 2 times 12 is 24. Okay, so we will subtract these now. We'll subtract the second one from the first. 9x minus 8x gives us 1x. Our 6y's will cancel, so that gives us 0. And 90 minus 24. So what is that? 8 minus 2, 66. Okay, so x is equal to 66, right? And then for y, we can substitute back into either of these, or we can substitute into either of these. Okay. In fact, I'm going to use this very first one. So if x is 66, we'll have 66 over 2 plus y over 3 is equal to 5. Okay, so 66 divided by 2 is 33. And what are we going to do? Minus 33, so y over 3. 5 minus 33. So 8. 28 and negative 28, right? 5 minus 33. Okay, and then we'll multiply by 3. Oh, it's tough. So we've got 24, 2 times 3 is 6, plus 2 is 8, so negative 84. Okay, so we've got x is 66 and y is negative 84. Okay, let's check those. Oh, good. Okay, that one's right. The other two we did were right. Okay, perfect. The last thing that we're going to look at is graphing. Again, I will just show you, I think the first one. Yeah, that's a good one. So I'll just do that example with this very first one, and then we're done. We won't do this a lot in class, but I just want you to understand when we're solving these equations, what we're really doing. So we're looking at, these are linear equations, and we can tell because x is to the power of 1, y is to the power of 1. Okay, nothing is squared, nothing is cubed, they're all just to the powers of 1, so they're linear, they form a line. We can graph those lines, and we can look at where these equations intersect, and that is the solution to these equations. Or you can use the substitution method or the elimination method, and you will get the same thing. So you can do algebra or you can use geometry. So geometrically looking at this, let's solve these equations for y. So we get y equals mx plus c. Remember, m is slope or gradient, and c is the y-intercept. We'll look at this again soon, but this is just a good review. Okay, so we're going to solve this first equation here for y. So we get it in this form. So we've got x is 2y equals 9. Well, minus x, 2y is equal to 9 minus x. We'll divide both sides by 2. And we get y is equal to negative 1/2 x. And plus, right, because in front of the 9 is positive, a 9 over 2. Okay, so our slope, that means 9 over 2, by the way, is 4.5. Okay, our slope is negative 1 over 2. Our y-intercept is 4.5. So we will start at 4.5. So 1, 2, 3, 4.5. So that's this point here. Is our y-intercept. It intersects the y-axis at that value, and this slope is telling us to go down 1 because it's negative, so down 1 and then right 2. Okay, so we'll go down 1 and right 2. Down 1, right 2. Down 1, right 2, and so on. Oops, that's not 2. 10, 1, 2. Okay. And we can keep going, right? And we draw a line through all of our points. We can also go up 1 and left 2. Same thing. Okay. So we can visualize our line. I'm afraid if I try and draw a line, it'll get all squiggly. Okay, next equation, we're going to solve this one for y. So we have y equals mx plus c, so we've got x minus y is equal to 3. If we, what can we do? We can add y to the other side, and we can subtract 3. So we get x minus 3 is equal to y, or y equals x minus 3. Okay, so that means we have a y-intercept of negative 3. So 1, 2, negative 3. And we have a slope of positive 1. 1 we can write as 1 over 1. So that means we go 1 up and 1 to the right. So 1 up, 1 to the right, 1 up, 1 to the right. Okay. And so on. And we could continue this way too, right? Okay, so these are our lines. And a line has an infinite number of points, right? And they are all connected. Let's try and connect them. Okay, so when we're solving these systems of equations, we're looking at where do the two lines intersect. And we can see that these two lines intersect at the point 1, 2, 3, 4, 5. So 5, comma, so x is 5 and y is 1, 2. Okay, and that's why the solution, whether we did substitution, elimination, or graphing, is that x is 5 and y equals 2. Because when we graph those lines, we get that they intersect at exactly that point. Okay, thanks a lot.